In this example, it looks like we have the integral of a pretty big rational expression. And so our mind immediately starts to think, okay, how are we going to integrate this guy? Fractions always make us think of the log rule. So log rule is always something we should check. I think after a quick little analysis, though, I don't think that's going to work because the numerator is not the derivative of the denominator. And I don't think you can make it the derivative of the denominator. There's no algebra steps or anything like that. But I do have another option. A lot of these guys are partial fraction decomposition if the denominator factors sufficiently well. Now it is a cubic, so we might have a good bit of factoring to do, but at least that's worth a shot. So let's take a look at it. X cubed minus 4x squared plus 4x. One thing that catches my eye right away is the fact that you could pull an x out, right? This denominator here, you pull an x out, and your remaining terms would be x squared minus 4x plus 4. And so that's a linear factor times a quadratic, but remember, we don't stop. If we could keep going, we want to keep going. I don't want to call this a quadratic if I could break that down even farther into a linear times linear type of deal. So it looks like this guy can factor further. It would be x times x minus 2 times x minus 2, which is actually x times x minus 2 quantity squared, right? Quantity squared. So it looks like this is really our denominator for this integral here. So yeah, I think this is going to be a decomposition problem. So we have to decompose it appropriately. But then the good news is when we integrate, all we would have to integrate are individual smaller rational expressions, not this one giant one all at once. All right, so let's set everything up and let's see if we can create our template and all that good stuff. I don't need the integral to do the decomposition. I'll integrate after I've decomposed it. So we'd have x squared plus 3x minus 4, x squared plus 3x minus 4 divided by x times x minus 2 quantity squared. Right, and if you'll recall, the decomposition depends on what these denominator factors look like. This is linear, and this is also linear even though it's repeated. So these are two linear factors. So what is this guy going to contribute to the decomposition? Well, he would contribute an a over x. Only that one term because he's only to the first power. Now the x minus 2 squared, on the other hand, is going to contribute two terms. Why two terms? Well, because he's squared. So I'll go ahead and put plus blank and then plus blank again. Right, plus blank again. Now what are your two denominators here? Well, the first one would be x minus 2 and the other would be x minus 2 squared. Because you recall, the reason you're having these multiple terms is these denominators increase in power by 1 until you get to whatever this number is. So if it was x minus 2 to the 5th power, you have in the decomposition x minus 2 to the 1st, then the 2nd, then the 3rd, then the 4th, then the 5th. So you'd have 5 terms contributed from this guy. But in this case, we only have 2. The numerators are both constant. We'll call it b and c. They have to be different letters. Because this factor is linear, the x minus 2. And so now the only objective is to find the specific a and b and c for this decomposition. All right, the way we're going to do that is we're going to multiply the left side and the right hand side by the LCD, right, by the LCD. Now who's the LCD? Well, this denominator right here is the LCD, right, the x times x minus 2 squared. All right, so forgive me for jotting this this way, but I'm just going to write LCD times the left and the LCD times the right, simply because I don't have space to write it out. But on your paper, you would probably want to write x times x minus 2 squared. That's what you should write on both sides, right? So I'm being a little informal here. All right, now, if this is your LCD, if you multiply that same LCD on the left, they're just going to cancel. So you would have x squared plus 3x minus 4 on the left. Now, what would you get if you distributed this LCD through on the right-hand side to these three terms? Well, the first term would have an a. The x would cancel because it's a over x, but you would have an x minus 2 squared. That's good news. You would have a b. It would have an x, but you would only have one factor of x minus 2 because one of these factors canceled, right? So it wouldn't be x minus 2 squared. The last term, on the other hand, has a c and an x because the x minus 2 squared, both factors canceled. So no fractions. This is pretty good news. From here, what we're going to do is we're going to use a shortcut to figure out the a, the b, and the c. And the shortcut goes like this. All right, because this is an identity and this is always the same thing as this, then you can choose any x of your liking, right? Because this equality should hold. So let's be smart about it. Let's pick an x that would make an a or b or c go away. I'm thinking like 2. What if x was 2? Then the left-hand side would be, let's see, 2 squared is 4. 3 times 2 is 6. 4 and 6 make 10. 10 minus 4 makes 6 on the left-hand side. And if you plug 2 in the right-hand side, this term goes away because you have 2 minus 2, which is 0. As does this term. It goes away because you have 2 minus 2, which is 0. So you really have 2c, right? Really just 2c on the right-hand side. And, automatically we see that c must be 3. That was so fast and short and quick. That was such a good little technique there. All right, let's do the same thing. What would be another good x value? I'm thinking like 0. I'm thinking like 0 because 0 would make the c go away as well as the b. 0 plus 0 minus 4 is negative 4. 0 minus 2 is negative 2. Negative 2 squared is 4. So we have 4 times a. So a is negative 1. Right? That's pretty good. Right? Now this problem has a little twist. The previous examples that we did not have this problem, but here's a very common issue. Matter of fact, I'll even change the color so we can see the difference. If I'm looking for another x that would make the a and the c go away so that I can find b, because I don't know b yet, I run into a snag because the only x's that would make b go away, I'm sorry, not b, a or c go away would be either 2, right? 2 would make a go away, or 0, which would make c go away. But the problem is 0 makes b go away, and 2 makes b go away. So we're in trouble either way. So we think to ourselves, man, what in the world? What am I supposed to let x be? Well, here's the simple observation. Let x be anything. Let x be anything in the world, like 1 or negative 1 or 10 or 100. It doesn't matter, and I'll explain why this works. Because we've already found a and c, matter of fact, I can take these guys right now and substitute them in. Right, let me take this a out, and I'll take this c out. And in their place, I'll plug in what they were equal to. A was negative 1, and c was 3. Then really all you have is not a, b, c, and x. You really just have b and x, right? You really don't have an a and a c anymore. So just pick anything to be x. Matter of fact, just don't let it be 0 or 2, right? Because we want this b to hang around. So let's try 1. Let's try 1. 1's not going to make anything go away, but it will allow us to solve for b. Let's do it. 1 and 3 make 4. 4 minus 4 makes 0. And then 1 minus 2 is negative 1. Negative 1 squared is 1. And so you'd have negative 1. 1 times negative 1 makes minus b. And plus 3. Right? Do a little algebra. Negative 1 and 3 make 2. So you get 0 equals 2 minus b. Or b equals 2. Right? b equals 2. So yay, we found the a, the b, the c, and we can come back up here and write the decomposition. So that's really good news. So a over x, b over x minus 2, c over x minus 2 squared can be specifically defined now. So I'll tell you what, let me erase this. Okay, and integrating this guy is the same as integrating, let's write them down. A over x, so negative 1 over x. We would have b over x minus 2, so 2 over x minus 2. And lastly, c over x minus 2 squared. C over x minus 2 squared, so it would be 3 over x minus 2 quantity squared. And let's see what that would lead to. Dx. All right. Just because this video is getting long and I have confidence that you guys can do all three of these integrals, I'm going to let you guys finish these. I'll go ahead and write down what the answer is so you can match it up with your work. Negative 1 over x, you can hold the negative and make it negative natural log of x, absolute value of x, because the integral of 1 over x is natural log. Plus, save that 2. Then you'd have the natural log of x minus 2. That's a log rule, pretty straightforward log rule. This one here would be a u substitution. Now this has a couple steps to it, but I'm not going to do these in this video. But at the end of the day, it would be minus 3 over x minus 2. Okay, so I'd like for you to check my algebra on this last one. Specifically, do the u substitution on this guy and make sure that you get the same answer as me. And then of course we'd have a plus c at the end because it's an indefinite integral. So this is about as big as they get. Hopefully by now you've understood the general idea behind partial fraction decomposition. You have a big ugly rational expression. You decompose it into smaller pieces, and then you integrate each piece, and that's pretty much how it works.